Distributions of one variable. A review in preparation for an investigation of the normal distribution. Every analysis of the distribution of a single variable is based on analyzing frequency. What does this mean? This is very clear for a categorical variable and much more difficult to conceptualize for a measurement variable. For measurement variables, a histogram is a frequency distribution in which each bar represents the number of cases for a range of values. So we have 80, this will be 90 here. So each bar is a range of 3.333 repeating. The values are listed along the horizontal axis. To know about the variable, e.g. the final mark of Math 11-12, means to know how many respondents got each of the scores. So we have the word, that's why we have frequency here. For the dot plot, it's pretty straightforward to understand frequency. For the histogram, it's less so. And as we move to the next slide, we'll see that percents are related to frequency as well. Frequency distributions can be true frequencies, for example, the dot plot, or relative to the total, which is just frequency as a percent. And pie charts are one way of illustrating this. So you have the color of Smarties, frequency distribution, and we have it as a bar chart with percents. And each of these is a percent of the total. So let's say 21, 21, 25, this is maybe 6. So we have 75% now, and this is roughly around 16, 75, 81, 91, and this is roughly 9%, which gives us a total equals 100%. Pie chart represents the same values, the same as these dot plot. So orange is 8. 1, 2, 3, 4, 5, 6, 7, 8. Yellow, roughly 16%. I wasn't too far off in my estimates. This is true frequencies. This is percents. And these percents are here, but the true values are also here. Distributions of measurement variables can be described by shape, center, and spread. Keyword is can be. Given the values to the right, you should be able to draw a pretty good sketch of the distribution of what the final marks would look like. So we have a mean of 68. We have a median of 70. We have skewness, negative 0.6. So they would look roughly something like that, right? With a maximum of 97. So this would be 97 here. A minimum of 17. And then we'd have the mean somewhere here at 70. This is a measure of center, and the median here. And the mean, of course, is going to be below because it's affected by, let's call it 69, and that's mu. Okay, so I can get a fairly rough but accurate sketch of what the distribution would look like. And so here we're going to get the exact shape based on the same values for mean, median, standard deviation, and so on. We get a histogram that looks like this, and we get a box plot that looks like that. And the key thing here is this, so this is the value of the median, roughly in that spot, and you can see that that's roughly 70, halfway between 60 and 80, and that's where the median is here. Now, distribution of measurement variables need to be described by shape, center, spread because, and I'm going to give you a counterexample. And watch this. This is a distribution of a measurement variable using the methods of categorical. It makes no sense. And this is an extreme counterexample, but I think it gets the point across. And the point is that you cannot investigate each category, each value separately. Shape, center, and spread are not meaningful for the distributions of categorical variables. And in this case, we're going to investigate just the nominal. So if I use measurement techniques, SPSS does produce all of these values, but look at this. Knowing that the average color is 3.18 means absolutely nothing. Whereas if I investigate the frequency of each category, the valid percents, what I can see is that, well, looks like red's the most popular and brown Smarties are not very common or very popular, depending on what the question was. Shape, center, and spread can be meaningful for distributions of ordinal variables. They're a special case. But, and I want to make this case very clearly to you, it makes more sense to analyze the frequency in each category. Going back to the first slide, every analysis is somehow a frequency analysis. So if I look at the mean score here, so this is, I just made up these values. So satisfaction with our statistics course, the mean is 2.5, the median is 3. So those are all the same values scored from 0 to 4, where 0 is very dissatisfied and 4 is very satisfied. We can get some meaning from these. So we can use measurement techniques to analyze ordinal data. But it makes much more sense to say, oh, over 40% of the students were satisfied and another 15 were very satisfied. So that makes a total of 55 students who are either satisfied or very satisfied. And we have 10% plus roughly 5%, which makes 15% who are either dissatisfied or very dissatisfied. Shape, center, and spread can be meaningful distribution of ordinal variables, but again, I want to make the point. It makes more sense to analyze this using this pie chart rather than these values. And I hope you agree. If you have any questions about this or concerns, please make sure to raise them in class when we take this up. I want you to think about this very carefully. We'll call it a dark room moment. Because the analysis of categorical and measurement variables is an analysis of frequencies, we can look at the areas under curves, i.e., for measurement variables, in the same way as we look at areas in a pie chart, i.e., for categorical variables. The image to the left is a standardized normal curve based on a measurement variable. It is useful because we know that 34% of the cases are bright red, i.e., they are located between 0 and 1 standard deviation above the mean. Dark red, below the mean, is because it's a symmetrical distribution, is also 34.13%. The mean is set as 0. This is 1 sigma, 2 sigma, 3 sigma. You will learn about these as z-scores in the next week or so. This works in the same way as the pie chart. Here, if we take 5%, we know that 5% of all the cases responded that they're very dissatisfied with the course. And so we mark them as blue. In this case, the blue is 13.59%. These are frequencies labeled as probabilities. And remember, probability is related percent of total. And that's the same thing we have here when we have percent. We have percent of total. So quite a bit to think about with this last slide. The key thing I want you to get from this is that this is areas under the curve, just like this is the area within a circle. The totality of the circle is 100%. The totality of the area here is also 100%. Thank you, and see you on Tuesday.